Hey, g'day, it's Prezzo here, back in the shop today, and I must thank Dean, who sent me this awesome sticker all the way from San Jose in California. And Dean runs a channel called the Air Cave Shop, and he does some interesting stuff over there, and he owns a Bridgeport, so he must be a pretty good bloke. And the thing I love was he sent me this envelope all the way from California, and there are 3 stamps on there, and each one of those has a value of 41 cents. And that's the thing I love about the USA. Now here in Australia, if the true value of the stamp was 41 cents, they'd round it up to 50 cents and say, no, screw it, you can pay 50 cents. We don't have to give you any change. But in the US, you pay 41 cents and you get 9 cents change. Isn't that awesome? Now, what are we doing today? Oh, that's right, we're going to catch up on the Bridgeport mill, and we're going to take a look at the DRO scale that I fitted in the last episode, and we're going to replicate the rapid prototype plastic parts that are used to mock up the DRO, and we're going to make those from aluminium and do some anodizing and make a permanent fixture out of that assembly. So let's check it out over on the mill and see what we're going to do. Okay, well here's the DRO scale set up on the Bridgeport mill, and I demonstrated the method used to design and manufacture this in the last video, but it was only ever a mock-up. And what I want to do is to remanufacture these white parts in metal. Now the material that I've used here is 3mm thick acrylic, and it's great for a mock-up, but it's not durable enough for everyday use. And it's prone to shattering and fracturing, and if you were to bend it or bump it, there's a danger that it could actually just snap. So the important thing is that when I remanufacture these parts, all the hole centers and all the geometry is the same. So we're going to use the original design files that I created in Autodesk Inventor, and then I exported those as DXF files, and then the laser cutter reproduced those DXF files in these white acrylic shapes you can see here. So I'm going to demonstrate a method used to transfer the same DXF files onto the metal, and then we can use normal drilling and cutting methods to recreate these shapes. So the process I want to use here is to use my CNC milling machine and a drag engraving bit to mark this aluminium sheet. Now this is 3mm thick sheet stock, same as what I used for the acrylic parts, same thickness. And I put some blue layout fluid on that, so dicam, and then when we scribe through that we'll see the marks very clearly. Now initially I had the idea that I could do this in the laser cutter. And this is the same stock. This is 3mm aluminium sheet. I painted that with some black acrylic paint, and then I've lasered through that, and it gives you a very, very clear marked line. The only problem is that the laser does not mark the aluminium at all. The only reason we can see those lines is that we've vaporized the paint. And if we were to start cutting this and drilling holes and so on, we'd easily rub that paint off, and then you lose all your marking out. So although that is functional, gives you a clear marked out line, it's not very durable. So let's try this. I'm going to get this set up, and we'll scribe exactly the same marks that you see there on this stock, and then at least we've got a scratched line into the underlying material that we can still see. So that's made quite a distinctive scribe mark on there, and yes, I could probably mill all of that out on the same machine. Probably wondering why I'm not doing it that way, but I don't know, I just want to do this old school. These hole centers are fairly critical and they really have to be right. So what I'll do now is I'll set up a drilling program and we'll spot drill all of these positions, including this corner radius here, and then I can drill out those round corner radii, not have to worry about filing that to shape. So let me set up this drilling program. Unfortunately, I forgot to put some stock underneath this, like a spoil board, but I can at least spot the holes and I can finish drill them later. So we've got all our hole centers marked now, and I can take this off the machine. We'll go ahead and witness mark all of these edges. Now, witness marking is like a very light center punch mark, and it allows you to see when you've hit the line when you're doing your finish filing. And that witness mark will show up as like a V-shaped notch in the edge. Now, because half the center punch mark remains on the stock, I don't want those to be visible from the front face. So I've taken all this geometry and I've flipped it. It's really only important for this part here, but I flipped all the geometry so all the witness marks will be on the back when we're finished. So for this process of witness marking, we need to use a fairly fine ground center punch. Back in the day we used to call these prick punches, but the included angle on that point there is about 60 degrees. And I'm using a very light ball peen hammer for this. So it's a delicate process. We're certainly not going to be smashing deep holes into this material. And the idea is that you can almost feel the tip of that punch. If it's really sharp, you can feel it drop into the scribe line. Failing that, you need to use like a magnifying visor, which is what I'm wearing now, and look very closely. So the accuracy of your finished filing is as good as how accurately you place these witness marks. Now, on the straight lines, for example, this one here, you can space those punch marks further apart. So I put about 4 along this edge, and on the curves around this one here, we place them fairly close together, say about 10 degrees apart. So you can see there the marks are, fairly fine, and I've tried to hit the tangent points at each one of these corner radii. Now, the other thing I should mention is why do I have 2 outlines here? Well, the inside line is what I originally cut out of acrylic for the laser cut parts. And when I looked at those parts on the machine later on, I thought there's no reason why we can't add a bit of a margin to that to increase the strength of these parts. And also, it's going to give me room for some countersinks around these 2 holes here. So for these 2 parts, which are the brackets which hold up the either end of the DRO, I've just added a 3mm margin all the way around. I'm just putting a few extras on these small corner radii, and you can sort of go back and add a few extras if you need to. Put a few extras on this large radius here. Alright, so there's that one done. You can see I put quite a few around this curve here, not so many on the straights, and I've got at least 3 on each one of these small radii here. Now these 2 holes here will be drilled, so I really don't need any marks at all there. That'll be taken care of by the drilled hole. I can feel the tip of that punch dropping into that scribe mark there. My eyesight's nothing like it used to be, so you tend to rely on touch as well as your sight. And if it's really quiet, you can hear the punch drop in there as well. See, I missed that one. Not paying attention, Mark. I'm going to put one a bit further back. Missed that one. Alright, so they're all done, and this is just like an insurance policy. So if for whatever reason you were to lose all your scribe lines here, we can re-establish our boundary because we have the witness marks and they're deep enough that it's pretty hard to obliterate then. That takes care of all the holes, so we can go ahead and cut all this out now. Just in case you're wondering, I covered up the laser on my little bandsaw. It's actually a bit of a nuisance sometimes. It covers up the line. It's so bright that it's very hard to see the scribe line. And if you're trying to cut to one side of that scribe line, it can be a bit confusing. So I just covered it up. I'll probably eventually put a switch in this. It's really just a gimmick. So there's our three parts roughed out, and what I need to do now is get on the belt sander and trim off all of the corners, do the corner radii, get close to the line. I'll bring you back when we're ready for the draw filing process. Here's a close-up of one edge that I've already draw filed just before I show you the big picture. Now there are witness marks just here. There's one there, one there, one there, and there's one at each extremity. And when you're doing the draw filing process, what you essentially do is cut those conical marks in half, and they show up on this filed edge as a V-shaped notch. Now there's one there, one there, one there, and they correspond with the witness marks on this front face. So what you need to do is begin the draw filing process, and then as you approach the line you'll see these notches start to appear. Now when they come to a sharp point or a V shape, you know you've actually intersected the line and you can stop there. Now the advantage of this is that when you're draw filing, you place the file at right angles across the stock and you stand directly above the file. These fingertips balance the file on that edge, and thumbs and fingers grip the file front and back, and then you work the file backwards and forwards. Now your head isn't really in a position where you can see the scribe line. You need to be looking from the side. But with the witness marks, they give you a warning that you're getting close to the line, and then you can stop when you reckon you're on the line. But you still do need to check from this side just to see how close you are. I was watching a video by Tom Lipton just the other day, and he's a man who likes his filing. And I don't know, I like it too. But one of the most important things is you keep your file clean. Now if you just pick up any old file, it's likely to have swarf and debris in the teeth of the file, and I found one of the easiest ways to clean it out is to use a piece of brass or a piece of copper. Now this is just a piece of tube that's been flattened at one end, and if you place that copper edge at right angles to the cut of the file or the grooves in the file and then work that across, it will very quickly form its own teeth at the correct pitch ratio to suit the file. And this doesn't matter what file you're using on previously, it will gradually cut new teeth and they go down into the valleys, and it will push out any swarf or grease or oil or dirt that's in the teeth, and this will give you a better chance of getting a clean cut. Just do that periodically, keep it clean, and of course the copper won't hurt the file. And if I do that both sides, you can see this is where I was draw filing previously. It's surprising how much dirt gets into that file. That's not bad, it's ready to cut again. Now this is the one that I'm working on now. I'll do this edge here, and there's a witness mark there and there, so roughly 1/3 of the way in from either end, plus the two corners. So let's see if we can find those, see if they appear. So once again, this is the grip, so those fingertips there go either side of the stock and they more or less balance the file at right angles. Thumbs go in the back and then these fingers in the front, and it's a backwards and forwards motion. And what we're doing here, because of the angle of the teeth, we're actually setting up a shearing cut, which gives you a shallow cut but a very controllable cut. If you were filing across the stock this way, it's more problematic. You tend to rock the file. Using a draw filing technique, it's much easier to keep it square. So have the file balanced so that you're not holding too close to one end or the other. It should be roughly balanced across the stock, so it sort of balances itself, and then all you're doing is pushing it backwards and forwards. Now, one of those witness marks is starting to appear just there. I can see that quite clearly. We're looking for the other one. It should be roughly there, but I haven't seen it yet. So I'm just going to concentrate on this end a bit. And you can see I might have got a bit too close at this end. Scribe mark is just starting to disappear. Actually need to do more at this end. Okay, there's the other one appearing just now. So there's one there, one there. So I reckon I'm pretty much on that line. There's another one appearing just here. Not quite sure, we haven't quite hit the other one yet, but we're very close. Okay, so now we've got 1, 2, 3. The other one might not be on the line, so I'm just going to stop there. So we go at this one. Now I'm looking for 1, 2, 3 marks. 4, there's one there. Alright, now there's one there, one there. You got one just starting to appear here, missing the one at this end. So you can see there the remains of the witness marks on the face, and you should just be able to see them glinting on that edge. So that's what witness marking does for you. It's sort of a visual cue as you're starting to approach the line. It doesn't replace you checking the material from the front face. Still need to do that, but this is just another level of reminder or accuracy, if you like, or warning that you're getting close to the line. You need to start reviewing where you're at. So on these curves, on these radii, we got more witness marks, so we got a better chance of seeing as we approach that curve. So I'm going to try and do that. And by the way, I've got plastic on the back of this stock just to protect it, because this is the face that's going to be anodized and visible from the front. Okay, let's try this curve. Of course, now you need to use very short strokes of the file. Alright, I've got a witness mark showing just there on the end. So I'm just going to roll this over a bit. And now I need to start blending the curve. Got a bit of a hard corner there, we need to blend that a bit more. It's not bad. Just using this old acrylic prototype part to get the 4mm hole through, which attaches the scale. And you sort of see now why I left the original outline scribed onto that material, because I knew that I would want to transfer that hole across. That's got that one. Now remember, this is the back of the part, this is the front, and I've countersunk those 4mm holes, and this is where our scale will attach. This plastic is just protecting what will be the front of this bracket. So I'm going to take that off now. And even though I had the plastic on there, there's still some bruise marks on the edges. There's some sort of a random punch mark there, I don't know what that is. And of course the back still has all the marking out. So as far as surface prep, I'm just using a piece of 240 grit sandpaper on a piece of softwood. And that cleans up pretty good. So it's starting to clean up, but I will have to pay attention to these little bruise marks and get them out. Just means a bit more work, that's all. And on the back, you can still see those scribe marks. On this one, they're still there, even though I've sort of rubbed that down pretty hard. But this whole thing is going to get anodized, and it's only this surface that we're going to see. So I'm not too bothered about those scribe marks being on the back. Anyway, I'm going to go ahead and get all these prepped, and then we're going to get them anodized. I won't show you that because I've done that process on some of my other videos. But we'll come back when these are ready to go on the machine. And yeah, look at my filthy hands. Well, here's the evolution of our parts. So these are the prototype parts here in white, and here's the finished metal parts now that the anodizing is done in black. And overall, really happy with the way that anodizing has come out. It's a good, rich, dark black, which is what you're after. It was a little bit thin in a couple of places, but I was able to fix that. And And you may notice that I've added a bit of metal around the top and bottom bracket. The middle one is identical. The reason I added the metal here was to get the rounded corners on that, just for safety and appearance sake, and also I wanted to countersink these two screws, just so that when it's all assembled it's all flush on the front face. Anyway, let's get these on the mill and see it all finished. I've just done most of this assembly off camera, but there are a pattern of 3 M3 screws, top and bottom, on the back of the reader, and you can use either set, doesn't matter. So I've got the screws there tightened up, and these won't be adjusted, so we'll get these locked down hard. And then the bracket assemblies have been done just loosely at this stage, and it's easier to do them like that, and when you're ready the whole scale just slides into those clamps. And then you can pinch these screws down to hold everything in place. But once again, we'll just do this lightly and get it on the mill, and we'll do our final checks and get everything locked down hard. At this stage everything's a bit loose, and what you can do is just simply raise the quill all the way to the top and then get all of this snug down, and you may have to go through that several times to get everything hooked up correctly. So it's the same deal here at the bottom, just run the quill all the way down and then tighten everything up at this end. Well, that's all working out. I'm really happy with the way that's turned out. I love the black look of the anodized material, and that's super rigid now. That's not going to move. Now, in my last video I showed this LCD here, and somebody pointed out that it was displaying incorrectly, and they said that this count should go negative as the Z moves downwards into the stock, and yes, that's the conventional way of doing it. Now, as it turns out, it's not going to be a problem because I'm replacing this LCD with this. Now, this is Touch DRO. Now, this is an app that runs on any Android device. So I'm running this here on an old Samsung phone at the moment, but I'll probably get either an 8-inch or a 10-inch tablet to take the place of this screen here because it's a bit small. And this works as a full 4-axis DRO plus a tachometer, which is down here, plus a touch probe if you want to fit one. And I must thank one of my viewers, Cape Cod CNC, who put me onto this. I'd never heard of it before. And the app is free to download, but you need to purchase a Bluetooth adapter that sends the data from the read head wirelessly to the app. And I'm in the process of doing that now. And one of the things you can do with any of these axes is just flip the direction of the display. So even though I put this read head on basically upside down, it won't matter because I can just make this go negative on the Z if I want to. So that's coming up soon, and I have actually purchased 2 more of these iGaging scales, one for the X, one for the Y. And yes, I know they're not as accurate as a good quality glass scale, but I'm not chasing microns on this machine. If I can get 1/100th of a millimeter, I'm very happy. One of the good things about these scales is that they're relatively immune to coolant and metal dust and chips and dirt and so on. And for me that was a big bonus. So that's where we're at the moment with this this little project. I've got another project coming up very shortly, which is replacing the original numeric scale down here with a very cool DIY version, which was primarily because I was too lazy to buy one from the USA, so I made it myself. So we're replacing that one. We're also replacing the ones on the side of the head, and I'll show you that in the next video. So thanks for sticking with me through this rather long video, and I'm going to catch up with you again soon. Should only be about a week, and we're going to see some more cool stuff for the Bridgeport. Okay, I got a couple of things to do. So yeah, check you out next time. It's Prezzo signing out. Sorry I forgot about you.